Hey everybody, today we're going to talk about solving inequalities using multiplication and division. So when you multiply or divide each side of an inequality by the same positive number, the inequality remains true. So for example, I know that 6 is less than 10. That's a true inequality. If I were to multiply both sides by, say, 4, that's a positive number, I get 4 times 6, which is 24, and 4 times 10, which is 40. 24 is still less than 40. Okay? So, now, notice it says a positive number here. What would happen if I did a negative number? So let's say I took 6 is less than 10, and then I multiplied both sides by, say, I don't know, negative 2. Okay? So then I get negative 12 here is less than negative 20. Well, I know that's not true. Negative 20 is way worse. I mean, if I owe you $20, that's worse than me owing you $12. Okay? So this only works when you're multiplying by a positive number. Okay? And so we get this nice little multiplication property of equality here that says if A is less than B, then A times C is less than B times C, as long as C is greater than 0. Okay, because if it's 0, then you got a problem there because then it's all 0. Okay, what about if I divide? So I've got 4 is greater than negative 6. Okay, so what if I divide both sides by 2? And you know what? I should have written division. Okay, so 4 divided by 2 is 2. Negative 6 divided by 2 is negative 3. 2 is still bigger than negative 3. By the way, when you see this little arrow like this means implies. Okay? You're going to see that more and more as you get higher and higher in math. Okay, so again, it has to be true for as long as C is bigger than 0. So I'm going to get another property, the division property of inequality says if A is less than B, then A over C is less than B over C as long as C is greater than 0. So we can look at this again if we did something like this. If we said, okay, I've got 4 is greater than negative 6. And what if I divided both sides by negative 2 this time? Oh, let's use a dark blue. So I divide by negative 2 instead of positive 2. Well, then I get negative 2 over here is greater than 3. Well, I know that's not true. So again, this has to be, C has got to be greater than 0. Okay? So there you go. All right, solve x over 5 is less than or equal to negative 3. Graph the solution. All right, so x over 5. That really means x divided by 5. So I get rid of division by multiplying. So I'm going to multiply this whole thing by 5. So it's going to cancel the 5 over here. It's going to leave me with x. I'm still going to have less than or equal to, and then 5 times negative 3 is negative 15. Oh, wait, my number line doesn't go all the way to negative 15, does it? Okay, so that's a bummer. So I'd have to come out here and I'd have to go, okay, 11, 12, 13, 14, 15, 16. There's negative 15. There's negative 16, and so on. And so then I'm going to go ahead and it's less than or equal to, so I'm going to put a closed dot on negative 15. I want less than, so I'm only shading this side over here. So, wasn't thinking ahead when I put that graph on there. Okay. So you go ahead and try these two problems, okay? Solve the inequality and then graph the solution. Negative 0.5 is less than or equal to m over 10. And negative 3 is greater than 2/3 times p. Okay, so I'll give you a couple minutes, pause the video, do those two problems, then graph them, and then jump back on here and see how you did. Okay, so this one here, the first thing I'm going to do is I'm going to multiply this whole thing by 10. Because it's going to make this m over 10 just m. And it's going to make this negative negative 5. Not negative 0.5, negative 5. And that's an ugly 5, so we're going to erase that and put a nice 5 in there. There we go. Now, again, I don't like to have it doing this because I make mistakes, so I'm going to switch this around. The m is greater, so it's going to go here. It's going to be a closed dot because it's equal to. And I'm going to shade the greater than sign. So that's what you should have got for that one. Okay, this next one here. All right, so now when you look at this fraction right here, 2/3, that really means 2 divided by 3. So the first thing I'm going to do with this, I'm going to multiply the whole thing by 3. So that's going to get rid of this fraction. It's going to leave me with 2p over here. Okay, and over here I'm going to get negative 9. Now I'm going to go ahead and divide by 2. And I'm going to get p, and I'm going to get negative 4.5. Okay, and I don't like to write it like that. I'm going to write it like this. P is less than negative 4.5. Okay, so I'm going to go here. Negative 4.5 is going to be right here. Whoops, and it's an open dot. Be careful, because it's less than. So it's going to be, oh, that's not in the right place. It needs to go right here. And then I'm going to go ahead and shade that side. And I should probably label this, because that could be any fraction here. I'm going to probably label this negative 4.5. Okay? So hopefully you got both of those right. All right, solve this one. 6x is greater than negative 18. Go ahead and pause the video and do this, and then jump back on here and see how you did. Okay, so I'm going to go ahead and divide both sides by 6. I'm going to get x is greater than negative 3. Seem to have a lot of negatives on this thing. So I'm going to have an open circle here at negative 3, and I want greater than, so I'm going to shade that side. Piece of cake. Okay. The multiplication division properties of inequality. Case number 2. If you multiply or divide both sides of an inequality by a number less than 0, that causes the inequality sign to be flipped in the other direction. So here I know that negative 4 is less than 6. Okay? So what if I multiply both sides by negative 2? So negative 2 times negative 4 is positive 8. And negative 2 times 6 is negative 12. Now, I know that 8 is not less than negative 12, so what I need to do is I need to flip the sign to be greater than. And now it's a true statement. 8 is greater than negative 12. Okay, so we get these two theorems here. If A is less than B and C is negative, then A times C is bigger than B times C. And if A is less than B and C is negative, then A over C is greater than B over C. Okay. So let's try this one. Negative 3/2 n is less than or equal to 6. So I've got a fraction here. This is negative 3 divided by 2. I'm going to go ahead and multiply this whole thing by 2. So that's going to cancel this, leave me with negative 3n is less than or equal to 12. Okay, now I multiplied by a positive number so it doesn't flip this sign over. But now what I'm going to do next is I'm going to divide by a negative number. Okay, so that makes n, it flips this sign greater than or equal to and puts a negative 4 over here. Okay, so I got a greater than or equal to, I've got a closed dot at negative 4. I want the greater than side. So I shade the right. And I'm done. Okay. Let's try this one. Negative 3z is greater than negative 4.5. Okay, so the first thing I'm going to do is I'm going to divide both sides by -3. Okay, that cancels us out. That's z. Now I divided by a negative, so it's going to flip the sign. Now it's less than. Okay, now I'm going to get -4.5 over -3. So that's the same as 4.5 divided by 3. Drop my 5, that's going to be 1.5. Okay, so z is going to be less than 1.5. So I'm going to go over here to 1.5 is going to be like right here. Put an open circle. I should probably, since it's between the numbers, label it. And then I'm going to shade the less than side, which will be this side over here. Piece of cake. Okay, so here's the problems you're going to do. It looks like there's a lot of them, but they're not that hard. So we'll do those in class. I will see you next time, and I will talk with you later.